Hi, I'm Steve, and in this video, we're going to look at getting started with Visual Studio 2017 and Python, whether you've already got existing Python code, want to start a brand new project, or have code online that you want to bring in. Visual Studio uses the concepts of projects to organize your code, all of the files, all of the build settings, and the configuration.
Open projects will appear in Solution Explorer, where you can see all of your files, select any of them, and right-click to choose any properties or see what else you can do with them. If you don't already have a project, here's a few ways you can get one started. The first way you're likely to use is File, New Project. This window offers you a whole lot of templates that are built into Visual Studio, including basic Python applications, web templates, IronPython projects, samples, some machine learning samples, IoT. The most likely one you're going to want is the Python application, which is essentially an empty project, and the From Existing Code wizard, which will help you pick up existing Python projects on disk and bring them into Visual Studio. Another way to get started on a project is with this new From Cookie Cutter tool. Cookie Cutter is a command line tool that pulls down templates that have been published to GitHub, but here we've integrated it into Visual Studio. So you can search the online templates that people have published. You can double click any of these to go through the wizard and generate a project from one of these templates. And if you just want to start from a single file, you can go File, New File. When you select Python, you'll get the basic choices. Empty module will just give you an empty file for you to start coding straight away. Maybe you've already got code online on Visual Studio Team Services or GitHub or another service that you'd like to pull down. If you go to View, Team Explorer, this will give you the window to let you connect to these services, or to clone an existing repository from wherever you like.
Now you've got your code ready, check out docs.microsoft.com/visualstudio/python for more documentation, walkthrough, and videos to help you be productive as quickly as you can. Hi, I'm Steve, and in this video, we're going to quickly walk through installing Visual Studio 2017 with Python support.
You can download Visual Studio 2017 from visualstudio.com. And when your download is finished, this is what you'll see. This is new from previous versions of Visual Studio and provides a much more flexible way for you to select which components you need or want to be able to use. The interesting item here for us is Python development. Just select this workload and you'll get all of the core pieces that you need to do Python development using Visual Studio. If you look over at the right, you'll see we have more optional components that we can choose to include or omit as we like. Python web support includes a number of items to make web development easy. It includes HTML editor, JavaScript editor, CSS, templates for Django, Flask, and Bottle, and a lot of functionality there that's very helpful if web is the work that you're doing. IoT support is specifically for Windows IoT Core. If you're developing those applications, these tools will allow you to use Python. Python native development tools are the C++ compilers that you need for Python, and also some extra templates and integration to make your experience better in Visual Studio. You'll also be a big selection here of Python and Anaconda distributions that you can install if you don't already have Python or Anaconda on your machine. You may also want to look at the Data Science and Analytical Applications workload. This workload includes further functionality for F#, Python, and R altogether, as well as the R client and all the other Python options as well. If you're doing data science work or intending to use multiple languages for this kind of analytics, this is a very good option to get you started. Once you've made your selections, you can click Install and let it get running. After installation, you can modify, launch, repair, or uninstall Visual Studio from the installer. You can also find it in the Start menu, and if you ever need to get back to the installer, you can search for Visual Studio Installer to come back here.
Now that you've installed Visual Studio 2017 with Python support, check out docs.microsoft.com/visualstudio/python for more tutorials, documentation, and videos to help you get productive quicker. Hi, I'm Steve, and in this video, we're going to look at the Visual Studio 2017 integration for unit testing in Python. One of the most important things that you can do with a large project is include both unit tests and integration tests to make sure that your code is running well. Integration tests can vary wildly in how they look, but unit tests tend to follow a pattern that we can expand into the IDE to give you more useful tools. Let's have a look.
Here I have two projects. One is a library for determining the location of the planets at any arbitrary time and date, and the other is tests for this library. What I want to do now is look at the test classes. You'll see that I'm simply using the standard unit test module and its test case class, and I'm not having to do anything special to make this work. I can write my tests as I normally would for any Python project, but now in Visual Studio, when I open Tests, Windows, Test Explorer, you'll see that we've gone through all of your files and collected the list of tests that you've written. By bringing this list up to the front, we let you easily get an overview of the tests that you have, and you can click Run All to see what the current results are and how reliable your code is right now. When a test fails, we show you the output that came from the test and the call stack that led to it. This lets you jump to the location where the test failed and use the output to determine how to fix it. You can then choose to simply rerun all the failed tests, and that will quickly tell you that you've created the right fix. Since you may not always be able to diagnose exactly why a test failed simply by looking at the output, you can also set a breakpoint in your test or anywhere else in your code, and then right-click and select Debug Selected Tests. We'll go and start that test under the debugger, so when you reach that breakpoint you'll get interrupted, and you can debug just as you normally would in your code. You can step through to inspect why your code is not working the way you expect.
Testing is a very important part of producing correct code, and Visual Studio 2017 brings your Python unit tests to the forefront for you. Check out docs.microsoft.com/visualstudio/Python for more information about how Visual Studio 2017 makes you a more efficient Python developer. Hi, I'm Steve, and in this video we're going to look at the debugging capabilities of Visual Studio 2017 with Python code when you're running either an entire file or a complete project.
Here I have two open projects with some files in them, and one start button, which will start debugging when I click on it. We choose the file to start based on which project is the startup file, in this case project 1 because it's bold, and which file within that project is the startup file, in this case module 1, so when we start, you'll see that we're in Project 1's Module 1. I can change that in Solution Explorer by right-clicking a project and setting that as the startup project, or right-clicking a file and setting that as the startup file. So that now when I hit Start, we'll be in Project 2, Module 2. I can start any file I like at any time by right-clicking it, so I can start with or without debugging, or doing the same inside the file itself, so I don't have to change the settings if I want to run one particular file on its own. If I go to a more interesting demo script here, then we'll be able to see some of the other things that happen while we're debugging. I can set breakpoints at any point in the script by clicking in the margin. You'll see a red dot appears there. These settings allow me to set conditions so that we don't always break, or I can set actions to log a message rather than breaking into the debugger at that point. I can also disable and re-enable the breakpoint with that button. Now when I start running this script, you'll see that we simulate some input, and when we reach the point in the program where that breakpoint is set, it gets interrupted, and now we're in the editor at that point. From here, I can use the mouse to hover over any variables that I like and see their current values, and I can also see in the Autos windows the values of nearby variables. We can see the output of the program so far, and if I bring up the call stack, then we can see a list of the function calls that are currently on the stack. I can use these buttons up here for stepping through the program. Step over, step into, and step out. Or I can use the keyboard shortcuts to keep continuing the program. If I hit F10, we'll continue. You'll see that my guess is 10, the number is 16. I feel like cheating, so I'm going to modify the value to 16 and continue. Now I've fallen into this section of code that is protecting against my cheating by making it impossible to guess on the first go. We're about to go into this loop to choose a new number, but I don't want to do that, I want to win. So we're going to change the next statement by dragging this down here and just skip that bit of code. By moving this marker around, I can set the next statement that's going to execute. And then when I keep stepping, it's going to go through the normal path and we'll get to the end of the program with the result I hoped for, which is I guessed correctly in one guess.
Many Python developers love the productivity gains you get from an interactive debugger, and this is only the start of Visual Studio 2017's support for this. Check out docs.microsoft.com/Visual Studio/Python for more tutorials and videos about debugging your Python code. Hi, I'm Steve, and in this video we're going to start typing some Python and have a look at the editing features and support that Visual Studio 2017 has to offer.
I'm starting with an empty project here, and the first thing you'll typically want to do is add a new module. I'm going to start from an empty Python file named module, and the first thing I'm going to do is import something else. You'll see that as soon as I start typing I get suggestions popping up, including for all the packages that I can import. And that if I start dotting through this, then I'll see everything that's available here. When I want to create a class, I can do this using a code snippet. When I type class, you'll see that it has this icon next to it, indicating that it's a code snippet, not just a keyword. That means that I can hit tab after typing it to get a code skeleton that I can then fill in. I can use a similar snippet to create a member function. And because we know the base class of this class, I can get a list of overrides here for functions that I may want to change the behavior of. You'll see that I get collapsible blocks for the class and the functions, and in fact you get these for any statement that's more than a couple of lines long. Let's add a new package to this project now. A package is going to be a subfolder with a name that's importable by Python code because it includes this init.py file. From this package, I can import the module that I just started. From there, I can access the class that I just created, and I can instantiate that and go and call my function on it. And you'll see that everything's being highlighted with it with the colors. We recognize the module, we know that this class is a class, we know that this is a function. I can right-click this and say go to definition, and it will take me back to where that function's been defined.
This is just a small taste of the editing support that Visual Studio 2017 has for Python developers. Check out docs.microsoft.com/Visual Studio/Python for more tutorials, videos, and information to help you be even more effective. Hi, I'm Steve, and in this video we're going to look at Visual Studio 2017's support for managing multiple Python environments, including Anaconda, and look at the most effective ways to choose which version of Python you'll be using for which part of your code at any time.
The home page for this is the Python Environments window, which you can find under View, Other Windows, Python Environments. This window will display a list of all of your installed copies of Python that we've detected, whether they're Python or Anaconda or something else. It also allows you to add a custom one if we happen to have not found something. Each of these items has a number of panels you can look at. The first, Overview, will let you know whether this is the default environment, and we'll come back to that. We'll give you a link to the website where you can get more assistance, and some settings as well as some shortcuts to open the location where the interpreter is installed. If I click to another, you'll see that this environment can be made the default environment for new projects. This one's marked as bold because it's already the default. When you make a new project, or if you don't have a project open, this is the environment that will be used, which means in this case your code would run with Python 3.6. Your interactive windows will work with 3.6, and we assume that you want IntelliSense from Python 3.6. You can change this from any individual project or interactive window later on. Next we have a list of packages. This is where you can see listed, install, uninstall, or update packages from your Python environment. You can see I have a number of packages already installed. Some of them have updates already available. Clicking this will update it. The X will uninstall the package, and I can search here for any, either a package I have installed or ones that are online that I may want to install matching that name. Third, we have the IntelliSense category. This section gives us a list of all the packages that we've detected and pre-analyzed. When we pre-analyze, this means that when you start editing, we can give you completion straight away. But because it is an extra step, you may occasionally need to review this list, see which packages are not up to date, and use the refresh button to bring them up to date. Custom environments that you've added will have an extra item here to let you configure, change the settings, or remove it.
Now you know where to find and manage your Python environments. Check out docs.microsoft.com/Visual Studio/Python for more documentation, tutorials, and videos where we'll walk you through everything you need to know to be most productive with Visual Studio 2017 and Python. Hi, I'm Steve, and in this video, we're going to look at executing just a few lines of Python code at a time in Visual Studio 2017. If you're using Python for data science or analysis work, this is likely to be your main workflow.
The interactive window is where you'll do most of this work. You can find it under View, Other Windows, Python Interactive Window, or by pressing Alt-I. Here, you can type any code you like, just as you would in the editor, except this time when you finish a statement, it's actually going to execute it and display the results. If you have a file open, then you can use Control-Enter shortcut from the editor to send line by line into the interactive window and see the results immediately as a full statement is completed. From this toolbar here, you can choose the environment that you're working against. This button will let you open a new interactive window with the same environment, or let you change it. From the Python Environments window, you can set the default that will be used by changing the default environment, or open any interactive by clicking on the Environments Interactive Window button. You'll see here a checkbox for Use IPython Interactive Mode. If you have IPython installed into your environment, as you do by default with Anaconda, then you can use this more advanced mode to perform inline plotting and use more advanced commands in the interactive window, just like you would in a Jupyter Notebook or an IPython Interactive Console. Finally, if you want to send more than a single line at a time, we have support for code cells. If you have a comment marked with this at the start, then that indicates a code cell. You'll see that this entire block is collapsible, and if I use Control-Enter anywhere inside this block, it's going to send the entire thing in one go to the interactive window and execute it. I can Control-Enter through sequential blocks and see the results as I step through them popping up in the interactive window.
So there's a starting point to get you going with interactive Python. Check out docs.microsoft.com/Visual Studio/Python for more ways that Visual Studio can help you with all of your Python development. Hi, I'm Steve, and in this video, we're going to look at profiling your Python code with Visual Studio 2017. It's common to think that your code is not running fast enough, but it's not always easy to see exactly where it's slow. Visual Studio integrates function-level profiling to give you this insight.
Here I have some code taken from the CPython benchmark suite, which we're going to do some performance analysis on. It's already in a project, so I'll click Analyze and Launch Python Profiling. Here there are two options, working with an open project, which I already have, or I can switch it to use the standalone script settings. If I do this, I can choose whichever Python interpreter I like and specify any script, working directory, and arguments. While analysis is running, I can leave it run for as long as I like, or I can cancel it at any time, and the data that's been collected is now going to be analyzed to produce a performance report. This report may take some time depending on how long you let it run for, but for short runs it's going to be fairly quick. So you'll see here in the summary page both the hot path and the functions with the most individual work. So looking at the hot path, we can see that permutations and a generator expression are taking the longest time in this code, and functions with the most individual work confirm this. Permutations is right at the top. If I click on this, we can investigate the function itself and see that this is the big function that's doing most of the work, and the one it calls into that does 18.9% of that is a generator expression. If I want to look at some other useful views, from this drop-down I can go to the call tree and use the hot path button to expand out to see the hot path. This gives me some more specific numbers in the table, and also lets me expand and dig into the parts of code to see which bits are calling which. I also have the functions view, which is a flat view of all the functions with the number of calls and the amount of time spent in each one. Each of these columns is sortable, which gives you a great way to inspect and really dig into the functions that take a long time and compare it with the number of calls to that function. The amount of time spent in a function doesn't necessarily mean that it's a slow function. If it's only called once, it may just be your entire program. If it's called many times, even with very little time spent in the function, you may still want to find a way to reduce calls to it to avoid overhead.
Profiling your code gives you a lot of information to help you make smart decisions about where to invest your time optimizing. Check out docs.microsoft.com/visualstudio/Python for more information about how Visual Studio 2017 makes you and your code more efficient.